Is this set of three vectors a basis for R3? There are two things that we need to check here. We need to know if these vectors are linearly independent, and we need to know if they span R3. So we actually get it at the answer to both of these in the same way, and not surprisingly, it's Gaussian elimination because that's what we do in linear algebra. So to check if these are linearly independent, we put the vectors into an augmented matrix with the zero vector. We want to know if the trivial solution is the only solution of this system. If it is, then these three vectors are linearly independent. We do the Gaussian elimination. We get 1, 0, 0, 0, 1, 0, 0, 0, 1. So the solution, there is only one solution, and the solution is the trivial solution, x equals 0, y equals 0, z equals 0. So the set is linearly independent. And that's one thing we need to check. The other thing is, do these three vectors span R3? And that span means, does C1 V1 plus C2 V2 plus C3 V3 equal B for any B in R3? Or in other words, is there some linear combination of V1, V2, and V3 that's going to equal B for any B in R3? And, what that comes down to is the same thing. If we wanted to see if we could add these three vectors together and get some V, some B, it's the same Gaussian elimination process on the left-hand side of this augmented stuff. I don't know what these numbers in here would be. They'd be combinations of B1, 2, and 3 times other things that would occur as we go through Gaussian elimination, but we would still get the identity matrix on the left-hand side. We would still get this on the left-hand side, meaning there would only be one solution, and there would be a solution. So there is some set of constants such that we can find a linear combination of V1, 2, and V1, V2, and V3 to equal any vector in R3. In other words, we can reach any vector through a linear combination of V1, V2, and V3, and that's what it means to span the set. So this set of vectors does span R3. I guess I should write that down. So these do span R3. And so we have a linearly independent set that spans our subspace, which means we have a basis. So this is actually a basis for R3.